Thank you. So welcome back. I hope everyone is settled now, and let's focus. Let's talk about the cost optimization, how we can save some cost with our new tool. So yeah, we are, before we start, I think let me introduce myself. I'm Ajit Gosavi. I work here as a senior, not senior, I'm ambitious more, I think, but specialist, a specialist cloud engineer. So, and what we developed is like basic wrapper. We abstracted out the complexities. Like when someone wants to interact with Kubernetes, there are a lot of complexities. You have to deal with like YML configuration that you are not aware of. And many of us are like from the data background, and they don't want to deal with this kind of complexities when you want to run something inside Kubernetes. So let's see how Kube API streamlined the process. Agenda is like, we'll see project background, then what is Kube API, we'll go through the features, cost optimizations or cost estimates, I will say, and then future implementation. After that, we'll have Q&A session. Let me give you the background for this project. This is like not Kube API, but kind of parent project for Kube API. We'll see like what is the background for Kube API as well. So in our current project, what we do is like we solve the client's problem. Like client want to just focus on the data side of it. They want to write the transformation, they don't want to focus too much on the infrastructure side. Let's say like you work with different cloud providers, but you don't want to deal with the complexities of Terraform, or you don't want to like always run the pipeline for provisioning something. It's a lot of effort, I believe. So what we did is like, we again extracted out complexities. Maybe client can have multiple projects. So we streamlined this process, we prepared automation suites around it. So whenever you want to onboard to the project, so client just needs to provide some details, and we'll provide him the workbench. Why it is needed? Whenever, if you're a client, you have less technical knowledge on Kubernetes side or Terraform side, then it takes a lot of time to set up all those things, like best practices. You don't know about like, which is the best thing or best thing in terms of like infrastructure, release processes. You don't have to worry. I will just run my, you can say Python code, or I will just run projects inside Databricks. I don't care like what is underlying there. So when someone onboards, we run automation in the background. This process is also automated. So you just have to go to on UI. We have UI front as well. You just input the parameters there. And then in the backend, we have some automation suites that will run. Your workbench will be provisioned, and immediately you can run your pipelines as well. So this onboarding and the workbench provisioning takes usually like few minutes only. And it is common for all the projects for that particular customer. So it can be customized for different projects. And you can see in this diagram, this is basically what we provide. I'm just giving you the basic example here. There could be different customization and a different tool set as well. But what we give is like a data factory, which is tied to like managed identity. And that managed identity can have access to storage account. So storage account, I need some orchestrator, as well as I need some logging tool. And all of this is covered, or this is secured using the Azure Defender. So you don't have to worry about like, where is my security? Like there will be like something, but everything is covered with this umbrella. So this is one example of the workbench. Let's go to Kube API then, and let's see what is the need for Kube API there. So first, so there was a need for alternative, but why? When we started working with this kind of workbench, we saw client is running a lot of jobs. Those are small in terms of lifespan, not maybe like long running, but small and those jobs don't have these kind of complex aggregations. So we thought like if we can run these jobs not in Databricks, we can extract them out, run somewhere where it is more cheaper and it is more easy to interact for the customers as well. So as a customer, I don't want to use complex tool. I can use some simple like a REST API maybe. So we did POC, small POC, where we tested luckily we had fleet of Kubernetes clusters already within the company for clients. So we used that, we did small POCs where we ran the jobs on Kubernetes, and we saw those jobs are costing less. If your project is having, let's say, 65K jobs, and those run daily, and those are small, short-lived jobs, then you can save a lot of cost there, because we'll see like about the costing, but we got tremendous results. We saved a lot of cost there, and client was very happy about it. Then we conceptualized, like the problem was there were multiple things that we have to take care. It is about the identity, it is about the user management. There were different things involved. We built one package that is Kube API. So it is nothing, but it is a microservice for job management. It is written in C#. Obviously, it is deployed inside the Kubernetes. So it is normal microservice that you can talk to. It has great operations, like you can create jobs, you can delete job, you can get the status, or get the logs as well. So all these teams, they don't have to create separate networks as well. I'm sure like you might be, you have already like having experience with the Databricks. If you want to run your workloads in private cloud or private subnet or private network, that is very problematic sometimes for infrastructure team, because we have defined limit for subnets and for IPs. If we are deploying that Databricks with VNet injection, management is like nightmare, I believe. Like you have to work with Terraform code, and something changes, some IP changes, then we have like multiple failures there. So it's easy, you don't have to deal with the networking thing here. Key feature, main feature is like it reduces the learning curve. Already all of us, like I believe, like use REST API calls, and we can execute these kind of jobs without any prior knowledge. And it's very easy. REST API endpoints can be triggered from anywhere. You can use your GitHub pipeline. You can use any scripts. You can even call it from Databricks as well, even from Data Factory, Azure Data Factory as well. So it's good, like if you feel like those jobs are like small, then it is pretty easy to call. Next thing is like obviously like we talked about the simplification. We don't have to deal with the YML complex files. It is cloud agnostic as well. This is a microservice. You can pick it up and deploy in any of the cloud provider. Now we are using some Azure, but immediately we can deploy it in Azure, and it will work fine with the minimum changes. The next thing is like obviously less infrastructure management. We talked about the Databricks thing here. VNet injection creates, so many resources. And I don't want to deal, I just want to post my job and forget about it. I want results. And I'm not worried about the scaling, how it auto scales, how it is accessing the storage account. I don't have to create those managed identities, those service principals. So there are so many things that if you onboard our Kube API, you don't have to create. You just have to provide minimum information. Again, it is cost effective. We'll see, I have detailed comparison here. So we can see the cost estimates. Let's say, assume a scenario where you're running a script or your job that runs for 15 minutes on Databricks notebook. And let's assume one standard machine which is having 4 CPUs. So the costing is Databricks will cost you for DBU units as well, and the standard machine cost. I haven't included the master node cost, because it is the, again, same other machine, like there are two machines that you have to deploy. Then the costing goes like 0.095. With spot instances, obviously you can save some of the cost. We'll get back to these estimates once we see Kube API estimates. So again, this is the same scenario with Azure Data Factory. Again, I'm using the 4 CPU runtime here for, CPU machine for runtime here, and the costs are like 0.0875. So it is again, you can save some cost with the Azure Data Factory, but it is not that exponential. And this is the Kube API. So compute is just built for that particular job run, and we are using Kubernetes. So let's say we are using, again, standard node, which is a Kubernetes, 4 CPUs. And if we see, we are just going to incur worker cost, because like we are already having Kubernetes cluster. Somebody is already running for their teams. We are just taking the node, attaching it, and running for our job. So this cost is, again, that comes to like 0.025 per execution. It is almost like you're saving like more than 50 or 60%. This is, again, you can enhance by by using the spot instances. This goes to, like, you can see, like, again, you can save again 90%, up to 90% cost. It is 0.0025. So that is exponential, I believe. Again, I mean, after cost, we had this, I think, a big purpose, that is governance. Because imagine, you can see, like, if client is having multiple projects, developers are used to like follow their own guidelines, like not exactly guidelines, but the best practices, I will say, in terms of infrastructure, like release processes, like even namespaces. I mean, I'm not talking about like namespaces, but they don't have a common grounds, like they don't have quotas as well. In Kubernetes, what we did is like we isolated the execution first. So every customer who onboards us, like they have separate namespaces, they have separate quotas. So not like I'm the customer, I'm using my 65K jobs, I will not impact other customers. So it's isolation. In the namespace, you can have your quotas, limit, roles required for running that particular job. So then we can go to identity management. So while you're running the job, if you want to access the Azure resources, let's say like Key Vault, a storage account, or any of the Azure resources, you need a central identity. So we are creating workload identity within this namespace as well. So you don't have to deal with a lot of identities. You don't have to set those identities with your pod. You just use it. It is already attached. You just fire the Azure CLI commands, or whatever. Like you can use even Python for that. Central policies. So I can give you one good example here. If you're connecting your Databricks to your storage account, or you can connect it from ADF as well, but by mistake, if you're having like 90,000 files in your storage account and you're doing ls commands, by mistake, I mean, it can happen. We are not like restricted. Anybody can execute that command, and that will incur like a lot of charges, I believe. So if you are creating your resources by yourself, you don't worry about those things too much, because you don't know those costs, and there can be expensive, those can be pretty expensive. So we are restricting all these kind of policies. We are restricting all these kind of operations, and we are providing timeouts between the connection. You don't make longer connections. We are providing caching as well. You don't have that caching with Databricks, but we have special adapters that we have configured. And yeah, the networking, I think I discussed already about the networking. You don't have to create too much of network. You don't have to worry about the IP address ranges and nothing like that, because it is already present in Kubernetes cluster. Future implementation, currently we don't have extensive monitoring with the Kube API. If you are the customer and then you are triggering a job, we are not giving you that much of extensive logs back through the REST API endpoints, but it is like few logs. You can see, but I mean, obviously, if you want to see more logs, then we can, I mean, we have in mind that we'll provide dashboards, like customized dashboard for every client. Then again, right now we are using Spot reserved capacity, and soon I think we will use the Spot instances. The next thing is optimizing the scaling in Kubernetes. Right now it is like autoscaler, Azure autoscaler present in the Kubernetes cluster. If your machine is exhausted of quota, then it will launch the second machine, the same exact replica of the second machine. But we can take, we can implement or integrate the tools, third-party tools like Carpenter. So that scaling will, if you're running already let's say 10 jobs, your machine got exhausted and you want to run 11th job, it will launch the smallest machine. It will not launch the exact copy of the machine. So we can, we have these kind of things in pipeline that we will implement and optimize the scaling.